Now, with the core basics and the foundation about React and its most important features out of the way and applied to our course project, we're gonna take the next step in this module. We're gonna have a look at 3 very important concepts which you need to know as a React developer. And that will be effects, reducers, and context. Now, these features are a little bit more advanced, which does not mean that they're difficult. This just means you need to know the other concepts first, which is why we are now diving into those concepts here. And with those features, you will be able to make a huge step forward towards more complex React applications. Now, in this module, we will therefore take a closer look at what effects are and how you can work with so-called side effects, which is what effects means, but more on that in a second. We'll have a look at how we can manage more complex state in our components with reducers. And we will explore app-wide, or at least component-wide state, so the state that affects multiple components, with a concept called context, which is built into React to make sharing state and state updates across components easier. A lot of important features that are included here, so let's not waste any time and let's dive right in. So what is an effect, also called a side effect? And I will use these terms interchangeably. So when I say effect, I mean side effect and the other way around. But what is that? Well, let's not forget that our components in the React app and our React app as a whole, and also especially the React library itself, has one main job: to render the UI, to react to our user input, to re-render the UI when it's needed. That is what we focused on thus far. With state and events and all of that, the main job was to bring something onto the screen and to make sure that the user may interact with that something and that what's shown on the screen may change based on certain events, for example, based on a button click or some text being entered. So therefore, that's the main job of React and of our application. We want to evaluate and render the JSX code and the DOM. We want to manage state and props to make sure that every component has the data it needs and that we reflect the user input correctly. We want to react to user events as mentioned. And of course, React is there to also re-evaluate our components and their JSX code and manipulate the real DOM as needed. So that's all baked into React with the tools and features we learned thus far and which we will dive into throughout this course, of course. So something like the use state hook, props, and so on. That's the main job. And if we have a look at a React component, this is a component from this module's project, which I'll dive into in a second. Then we learned that a component is just a function, therefore it's executed top to bottom, and everything in that function in the end deals with bringing something onto the screen and or with reacting to user input, to clicks, and so on. So that's what this function is all about. We may use state in there, we may have other functions in there, which for example are triggered upon a button press and so on. But everything we have in this component function is concerned with bringing something onto the screen. Now, therefore, side effects are everything else that might be happening in your application. And a good example here is sending a HTTP request or storing something in browser storage, in local storage, for example. But you could also think about timers or intervals which you set in your code. These are all tasks which you of course often have to consider in your application. For example, a lot of web applications need to send HTTP requests to backend servers, but these tasks are all not related to bringing something onto the screen, at least not directly. Of course, you might be sending a HTTP request to then draw something onto the screen once you got the response, but sending the request itself and handling potential errors and so on, That's not something you need React for. That's not something React cares about. That's not what React is there for. It's not something that is related to drawing something onto the screen directly or anything like that. So these are therefore tasks which must happen outside of the normal component evaluation. So outside of your normal component function. Because you must not forget that this function, this app function, for example, is re-executed by React automatically whenever, for example, the state in this component function changes. Whenever this isLoggedIn state would change here, this entire function reruns, and React then basically checks what the new result of this function execution, so the new JSX code, looks like, and if, compared to the previous result, it should go to the real DOM and make some changes there. And we'll dive deeper into how exactly React works under the hood in a separate section, but this is what you learned thus far, and this is what React does. Now, since this is what's happening, if we would send a HTTP request, for example, directly here, then we would send this request whenever this function reruns. So for example, whenever this state changes. And that might sometimes be what you want, but definitely not always. And if in response to your HTTP request, you, for example, eventually change some state, you would even create an infinite loop. Because you would send a request whenever the function reruns, and in response to the request, you change some state which triggers this function again. So therefore, such side effects should not go directly into this component function, because that would most likely create bugs, infinite loops, or simply send too many HTTP requests, to stick with that example. Therefore, we'll have a better tool for handling side effects, and that's a special React hook which we can use, the useEffect hook. The useEffect hook is simply another built-in hook, so another function you can run inside of your component function that will do something special. The useEffect hook is called with two arguments, with two parameters. The first argument is a function that should be executed after every component evaluation if the specified dependencies changed. And the specified dependencies are the second argument that you pass in. That's an array full of dependencies, and you will see how these dependencies look like throughout this module. So an array full of dependencies, and whenever such a dependency changes, that first function will rerun. And therefore, in that first function, you can put any side effect code, and that code will then only execute when the dependencies specified by you changed, and not when the component re-renders. So only when your dependencies changed. Now let's have a look at that in action, and for that I prepared a little project which we're also going to have a look at. So attached you find this project here. You can simply download it, extract it, run npm install inside of it, and then npm start, and you will see this page on localhost 3000. Now that's a very simple dummy app where you can enter any credentials of your choice. That's not a real authentication screen yet. For the moment it's just a dummy screen. As long as you have a valid email address and a password that is at least 7 characters long, you can click the login button and you're on this dummy welcome screen. These links won't do anything, but the logout button will take you back. So it's a very simple dummy app. At the moment, there is no real authentication logic. We'll dive into that in a separate module. But it is a good enough example to practice the useEffect hook and side effects therefore, and also the other core concepts of this module. So what's up with this useEffect hook now? Well, what could be a good side effect here? Sure, we could send a HTTP request to a backend server, which validates our email and password. But at the moment, we have no such server, so therefore I want to do something else. At the moment, when I log in with any dummy credentials, which are an email and at least 7 characters long for the password, if I click login, I am logged in this dummy mode, But if you reload this page here, you always lose this login status. And that is probably not something you want. Now, in reality, you would, of course, once you log in, send a request to the backend and get back some login data. For example, some token which identifies this user as authenticated. Again, more on that in the authentication module. But you want to make sure that this user is authenticated status is also still there once you reload the page. At the moment we lose this because in the app.js file where I manage this simple isLoggedIn state, it's just managed as some React state. And therefore it's just in the end managed in some JavaScript variable behind the scenes by React. Now, the nature of that is that when you reload your application, your entire React script restarts and all variables from the last execution are lost. That's how the web and scripts and the browser works. This is nothing React specific. Now, since we lose all the data when this restarts, it would be nice to store it somewhere where it persists the reload. And even better than that, we also want to make sure that whenever this app does start, we check if the data was persisted. And if it is, we log the user in automatically so that the user doesn't need to re-enter the details. And that's where we can use useEffect. Now let's start with storing the data. Here in the logged-in handler, I set isLoggedIn to true. And that's where I want to store that piece of information in the browser storage. Now the browser has multiple storages we can use. The most common storage for this would be cookies or local storage. And since it's particularly easy to work with, we will use local storage. So that's a storage mechanism built into the browser, totally independent of React. Here in the login handler, we could therefore run local storage. This is a global object which is available in the browser. Set item, and then give the item any identifier of our choice, like for example, is logged in. But that's totally up to you. It should just be a string though. And the second argument should also be a string, which you store. And for example, that could be 1 to signal that this is that the user is logged in. 0 could stand for not logged in. Of course, you could also have some identifier like this. This is totally up to you. I will work with 1 and 0. So we can set this item here. And if I do this and I save everything, if I do log in again here, I can open up the developer tools thereafter. And there open the application tab or the application part. There you'll find the storage section with the local storage. And if you expand this, you'll find your host, and there you should now find this key value pair. That's stemming from this line. So that's how we can store data. Now we can do this here in the function because it is a function that executes only when the user clicks the button, which is rare enough and which is exactly when we want to store something. So that's now a use case where we don't need useEffect necessarily. But how about the scenario that the app restarts because the user left the page and comes back, or simply because we reload the page? Then we want to check if in local storage we have that key value pair. Now, when the app restarts, this app component function runs again. Now, therefore, here, of course, in this function, we could reach out to local storage, call getItem and search for isLoggedIn, and this will return the item stored there. So that's the stored user logged in information. That's a super long name, obviously. I just want to make it clear what's in there. You would typically use a shorter name, of course. And we could check if the stored user logged in information is equal to 1. And if it is equal to 1, we could call set isLoggedIn and set this to true. So that we set the user to logged in even without this function being triggered. And it would trigger upon pressing the login button normally, just because we know that the user is logged in. And of course, we should do that after calling useState. So we could do that. But the huge disadvantage with that approach is that we would create an infinite loop. because we check for this being stored. If it is stored, we set this to true. And whenever we call a state setting function, this component function re-executes. And therefore, this would run again, would find 1, would set it again, and so on. That's what I explained earlier. So we need useEffect here, because that allows us to control when this runs. Hence, from React, besides useState, we import useEffect like this. And then here, we can simply call useEffect, just like this. And now we pass those 2 arguments you saw on the slide to it. The first argument is a function, for example here an anonymous arrow function. Doesn't have to be an anonymous arrow function, but often you use just such a function. The second argument is an array of dependencies. Now I'll come back to those dependencies later. For the moment, let's just write it like this. In this function, we can now run this code here, which we don't want to run directly in the component function. Because now this function here is executed by React, and it is executed after, important, after every component re-evaluation. So whenever this component function ran, thereafter, this will run. And if you then update the state in here, the component will run again. But it will not just run after every component evaluation, but only if the dependencies here changed. Now, when the app starts for the first time, that will be the case. If this component function runs for the very first time because your app just started, then the dependencies are considered to have changed because you had, well, no dependencies before, you could say. But once it ran for the first time, for example, with this setup here, we have no dependencies, but therefore, of course, they also didn't change compared to the first execution cycle. So therefore, this anonymous function here would indeed only run once when the app starts, because thereafter, well, the dependencies never change because this here specifically has no dependencies. And in this scenario, that's exactly what we want. We want to run this code once, and that's when our app starts up. So therefore here we should have exactly the behavior we want. Once the app started, this code runs. Here we update the state, and as you learned, this triggers this component function to run again. Now therefore this all runs again, this JSX code is evaluated and the DOM is updated accordingly, but thereafter the effect would run again, but only if our dependencies also changed. And that's not the case here, as I explained. So therefore, this should only run once. And hence, if we save that, and I reload here, you see I'm logged in. I don't end up on the authentication screen, but in the logged in state. And the reason for it is that we have this stored. Now, if I clear that manually by selecting it and deleting it, if I now reload, you see I'm back here. Because this code still ran, but of course it didn't find the logged in information. If I do log in again, so that this is stored, you will see we're back to the behavior from before. If I reload, I end up on this page. So that's useEffect, and that's one scenario where it shines a lot. This data fetching is a side effect. It's not directly related to the UI. Of course, the result is, but not the data storage access itself. And we want to run it as a side effect with useEffect in this case to avoid an infinite loop and to make sure that this code, which potentially could also be performance intensive, does not run for every component re-render cycle, but only if we want it to run. Now let's refine our data storage example here by also making sure that when we click the logout button, we again reach out to local storage and we remove the is logged in key there, simply to clear it from there so that we don't have to clear it manually by selecting it here. So we saw useEffect in action here in the scenario with no dependencies. Now, often you need dependencies because you don't just want to run this effect function once when the app starts up, but indeed after every component re-evaluation if a certain dependency changed. And an example can be found in the login component. That's the component where I actually render this form here. this form here. That's being rendered here. And as you see, there is actually some validation built in. If I click in here and I click out, you, for example, see this is marked as red. And also the button is only enabled if I have entered something valid in both inputs here, right? So otherwise the button is disabled. So we got some validation, and currently the validation works such that for every keystroke on the email field, this email change handler runs, and it sets the form as valid if the email contains an @ symbol and the entered password was correct. And we get the same for the password change handler. And I also got the validate email handlers, where I set email and password as valid whenever the inputs blur, so whenever they lose focus, so that they also are marked as invalid if I just click in there, enter nothing, and click somewhere else. Now, where could we use effect here? Well, for example, to restructure our validation logic here. Instead of having essentially the same logic, just, well, swapped basically, in the email and the password change handler, we could use effect to have one place where we mark the form as valid or invalid with one logic, which should trigger whenever either the email or the password changed. And that's where we will need an extra dependency. So therefore here, we can again import useEffect, and then here after our state definitions, we can call useEffect and pass this first function to it, and have our array of dependencies. Now in this first function, I will call setFormIsValid, but of course I will not use the event target value, but I will check if the entered email includes the @ symbol and the entered password is longer than 6 characters. Now, like this would only run once, and that's when this component first is rendered. So therefore, if I remove that logic from the password and the email change handler, you will see that I can reload this and I can type in there, and my form, well, this button never gets enabled. And the reason for that is simply that this effect only ran once, as I said, when the component rendered for the first time. Now, that was the right behavior in the app component with our login state. It's definitely the wrong behavior here though. We want to re-evaluate this and rerun this form validation state setting function for every keystroke in email and password change handler. Now, we could remove the dependencies array. Now, don't save this because this would crash your page. This would make sure that this runs whenever this component was re-evaluated. Therefore, effectively, in this case, it's the same as if we would have moved this code directly here into the component function itself. Because now, without any dependencies, this code reruns whenever the component was re-rendered, and since we set state in here, this would trigger a re-render cycle itself, hence we would have an infinite loop. So saying nothing about the dependencies is not what we want, but no dependencies is also not what we want. Then it would only run once. Well, indeed, there is a simple rule. You add as dependencies what you're using in your side effect function. So in this case, we are using the setFormIsValid function, we are using entered email, and we are using entered password. Includes and trim are only called on those entered email and entered password fields then. So we have setFormIsValid, entered email, and entered password. These are our 3 things we're using here. So therefore, here between these brackets, you would add setFormIsValid, entered email, and entered password, just like this. Important for setFormIsValid, you of course don't execute it. That would add the result of this function execution as a dependency, but instead you add it like this to add a pointer at this function, so that you essentially add the function itself as a dependency. And this tells React that after every login component function execution, it will rerun this effect function, but only if either setFormIsValid or entered email or entered password changed in the last component re-rendered cycle. If neither of the three changed, this effect function will not rerun. Now actually, you can also omit setForm is valid because those state updating functions by default are ensured by React to never change. So these functions will always be the same across re-renderer cycles, so you can omit them. Entered email and entered password could have changed, of course. To be precise, with every keystroke, one of them will change. So if we now save this, and we try this again, you see the login button still enables and disables. And the reason for that is that now this effect function reruns whenever entered email or entered password changed. So that's another scenario where useEffect shines. It helps us make sure that we have one code in one place instead of, as before, in multiple places, which reruns whenever one of the dependencies changed. And that's also something where you use useEffect. So it's not just for when a component was created for the first time, but it's equally common to use it to rerun logic when certain data, typically some state or some props, changed. Now, one aspect that could be confusing here is that, of course, now inside of this useEffect example, we're not working with local storage, we're not sending a HTTP request, we're not setting a timer or anything like that. Instead, we are updating the React state. And that could be confusing if you recall that slide from earlier where I had a slightly different separation. So to clear that confusion, you must not forget that it's called useEffect, and it has one main job. It's there to handle side effects. And often, side effects are HTTP requests and so on. But it's also a side effect if we listen to every keystroke and save that entered data, as we're doing it in the email change handler, for example, and we then want to trigger another action in response to that. So checking and updating that form validity in response to a keystroke in the email or password field, that is also something you could call a side effect. It's a side effect of the user entering data. So that's why this should not confuse you. useEffect in general is a super important hook that helps you deal with code that should be executed in response to something. And something could be the component being loaded, it could be the email address being updated, it could be anything. Whenever you have an action that should be executed in response to some other action, that is a side effect. And that is where useEffect is able to help you. That's just a little addition I want to make here. Now, there is one last important thing you need to know about useEffect, or about the built-in features of useEffect. We learned about this effect function, we learned about the dependencies with the scenario that we have no dependencies with an empty array, or that we have some dependencies. Now, sometimes you also have an effect that needs to do some cleanup work. And that sounds very abstract, so let me give you a more concrete example. Let's say here, we're executing this function essentially on every keystroke. This is what happens here. I can prove this to you. If I console log this, checking form validity, you will see, if we go back here to the console, with every keystroke, this runs. Now that's not a problem here. This function execution is fairly fast, but what you do in this function, that might be a problem. Here we are updating some state. This might already not be ideal. Now I'll be honest, for this simple state update it won't be a problem, but of course it means that it triggers another function component execution, and that React again needs to check whether it needs to change something in the DOM. So even that might not be something you really want to do for every keystroke. Now imagine you would do something more complex, like for example, send a HTTP request to some backend where you check if a username is already in use. You don't want to do that with every keystroke, because if you do, that means you're going to be sending a lot of requests. And I don't know about you, but that might be a lot of unnecessary network traffic. So that's something you might want to avoid. And as I said, even this year, this state updating is something you might not want to do on every keystroke. Instead, something you might want to do is that you collect a certain amount of keystrokes, or you simply wait for a pause of a certain time duration after a keystroke, and only if the pause is long enough, you go ahead and do your thing. So for example here, whilst the user is actively typing, I might not want to check if it's a valid email address. I care about when the user stopped typing. So for example here, when I type and then I stop for, let's say, 500 milliseconds or longer, then I want to check, okay, the user seems to be done, let's see if it's valid. That's something we might want to do, and the same for the password. Now that's a technique which is called debouncing. We want to debounce the user input. We want to make sure we're not doing something with it on every keystroke, but once the user made a pause during typing. And with useEffect, that's actually easy to implement. We can use setTimeout, which is a function built into the browser, to wait for example, 500 milliseconds until we execute some function. Now, in this function, we might want to check our foreign validity, or to update our foreign validity. Now we would only do this after 500 milliseconds. Now, if I move my console log in here, you will see that this alone doesn't do much. The only result is that we don't see the output immediately, but with a slight delay of 500 milliseconds. Which makes sense because for every keystroke, we're now setting a timer, and after 500 milliseconds, we do this. Well, the trick is that we actually save the timer, and for the next keystroke, we clear it so that we only have one ongoing timer at a time. And only the last timer will therefore complete. And as long as the user keeps on typing, we always clear all other timers. And therefore, we'll only have one timer that completes, and that completes after 500 milliseconds, which is the delay the user has to issue a new keystroke to clear this timer. Now that might sound complex to implement, but useEffect makes that very easy actually. In the useEffect function, so the function you pass as a first argument, you can do something we haven't done before. You can return something. Now the something you return here has to be one specific thing. It needs to be a function itself. So here you can also return a function. For example, an anonymous arrow function. But it could also be a named function, just as for all the places where I'm using anonymous functions. So we are returning this anonymous arrow function here. That's a so-called cleanup function. This will run as a cleanup process before useEffect executes this function the next time. So, to make it clear when this runs, whenever this useEffect function runs, before it runs, except for the very first time when it runs, this cleanup function will run. And in addition, the cleanup function will run whenever the component you're specifying the effect in unmounts from the DOM, so whenever the component is reused. So the cleanup function runs before every new side effect function execution and before the component is removed, and it does not run before the first side effect function execution. But thereafter, it will run before every next side effect function execution. So we can simply console log cleanup here to get a feeling for when it runs. If I reload this page, you see checking for invalidity ran. So this code ran clearly, our main side effect function code, but we don't see the cleanup call. We don't see the cleanup log because of what I said. It does not run before the very first side effect execution. But if I then type here just one character, you see cleanup runs immediately, and then the code inside of this side effect function, inside of this function here, this code here executed. So that's how cleanup runs. It runs before every new side effect function execution. So with this in mind, we can use the fact that setTimeout actually returns a handler, let's say, or actually an identifier for the timer that was set. And we can use this identifier to clear this timer with the built-in clear timeout function, which is built into the browser. So this has nothing to do with effects or with React. This is built into the browser. Now I don't want to run it here. I want to run it in my cleanup function instead. There I call clear timeout and pass the identifier of this timeout to it. And this makes sure that whenever the cleanup function runs, I clear the timer that was set before this cleanup function ran, so in the last side effect function execution, so that when the next side effect execution is due, we are able to set a new timer. So we clear the last timer before we set a new one. That's what's happening here. And again, if the order is not clear to you, have a look at those console log statements, this one, and see in which order they execute. So therefore now if I reload, we see checking for invalidity. And now if I type here, cleanup, and then again checking for invalidity. But now here if I type a lot very quickly, you see a lot of cleanups, but you only see one checking for invalidity. Again, let me show this to you. If I clear this, and now again, if I type quickly, only one checking for invalidity. And that means that this code in here only ran once for all those keystrokes. And that's what I mentioned earlier. If we would be sending a HTTP request here, we would have now only sent once instead of a dozen HTTP requests. And that's an improvement. And of course, also a nice example for this cleanup function and when it matters and how it works. And of course, needless to say that our form here still works as before, just with a slight delay, which you of course can control. You can lower this number here, fine-tune it to your needs. But this is a great example for the cleanup function and how it works. UseEffect, besides useState, is the most important React hook you have, so you need to understand it. Therefore, I again want to make it clear at which point of time, which part of UseEffect kicks in and executes. And for this again here in the login component, I'll add a new UseEffect call where I only add this first argument. So for the moment, no second argument. And in there, we can log effect running. Now, at the moment, we have no information about the dependencies. We just have this first argument. And this is a valid way of using it, though you will rarely use UseEffect like this. The reason for this is that if I reload, you see it runs when the component first mounts. So when this login component is rendered for the first time. But then also for every state update. For example, if I click in here and click out of there, we see effect running. For every keystroke, we see effect running. So this really now runs for every time this component function reruns. Because you learned this effect function runs after every component render cycle. Not before it and not during it, but after it, including the first time this component was mounted. Now, this changes once we add an empty array. Now, this function here only executes for the first time this component was mounted and rendered, but not thereafter, not for any subsequent re-render cycle. So we see effect running here, but for the keystrokes, we don't see it. Now, if I log in, we also don't see it again. So it really only ran once. Alternatively, we add a dependency like entered email or entered password. Now this function here reruns whenever the component was re-evaluated and this state in this case here changed. So if I now log out and reload, we see effect running for the first time this was mounted. But now for keystrokes in the email, nothing changes. For keystrokes in password, we see effect running though, because the password is a dependency. We also have the cleanup function, which we can return. This cleanup function runs before this state function as a whole runs, but not before the first time it runs. So here I will again log effect cleanup, save this. We see only effect running here for the first render cycle. For the email, nothing happens. That's a different cleanup log. This is coming from our other effect. So effect cleanup did not print yet. But once I start typing in the password, we see effect cleanup being triggered, and it triggers before the effect function runs. Now, if we had an empty array here, so no dependencies, we learned that we only see effect running once, and the cleanup function in this case would run when the component is removed. So in this case, for example, when I log in and the component is removed from the DOM, we see effect cleanup. So that's how useEffect works and how the different parts of it are related and when they execute. Really important to understand this. So if it's not 100% clear at this point, definitely go through those last lectures again to make sure it is clear. Now we just learned about useEffect, which I mentioned would be the most important React hook besides useState. Are you ready for the next React hook, useReducer? Now useReducer is another built-in hook, and it will help us with state management. So it's a bit like useState, but actually with more capabilities and especially useful for more complex state. Because sometimes you have more complex state, for example, multiple states that kind of belong together, that are managing the same thing, just different aspects of it. Or you have multiple states that kind of change together or are related. In such cases, useState and the state you get from there often becomes hard or error prone to use and manage. And it's easy then to write bad or inefficient or potentially buggy code, which is of course never what we want. useReducer is then an alternative to useState, so it's a replacement if you need a more powerful state management. Now this does not mean that you should always use useReducer, because it's more powerful, so it's always better, right? No, because it's also a bit more complex to use, it requires a bit more setup. So for a lot of scenarios, for the majority I would argue, you probably use useState. But there are cases where the extra work of getting useReducer to work is just worth it. That's all very abstract. What would be a concrete example? We can again go back to the good old login.js file here. Here, you see, I'm managing a couple of state snapshots, and you might be able to spot some related state here. We manage the entered email and the entered password, but then we also manage the fact or the question, the response to the question, whether the email or the password is valid, and we manage the overall form validity. So you could argue that overall, this is all one big state that describes the overall form state. The inputs are part of that. Or you at least treat every input as one entity and one state, which simply has two aspects: the value the user entered and the validity of that input. And it becomes clear that we have some work to do and some redundancy if we consider the fact that we're setting the overall form validity by checking the validity of email and password when we're doing the exact same thing here for our two validate handlers. Now we could rewrite this in various ways and, for example, use our email is valid and password is valid states here in this useEffect and just use those two states to confirm whether the overall form is valid, and that would work. But nonetheless, we at least have these two states, the entered email in this example and the validity of the email, that clearly kind of belong together and which we therefore might want to manage together. In addition, I want to come back to something which we don't have anymore because we're using useEffect, but what we had before. If I comment out useEffect here, before you might remember that inside of email change handler and password change handler, we had a slightly different code. We had this code here essentially not just in the email change handler, but also in the password change handler, where we checked the other entered value and the entered value for this handler with event target value, and we would derive the form validity from that. Now, this approach also worked, but we had some code reusage, which is why the effect was a better result. But let's say for whatever reason you don't want to take that route to use effect. In that case, you would have another problem, and I'm just going back to the solution to show you this problem, which you can have in some apps and in some use cases. Here, we are updating some state, the form validity state, based on two other states. Now, what did you learn about updating the state based on some older state? You want to use the function form, right? Now, this doesn't work here, however, because that's only true if your next state update depends on the previous state snapshot of the same state. But here we depend on two other state snapshots of different state, of the entered email and the entered password, not on the last state snapshot of the form validity. So therefore here actually we're doing something which you normally shouldn't do. Because of the way React schedules state updates, this code here could actually, in rare cases, but it could actually lead to the scenario where this runs before, for example, password state update was processed. So therefore entered password, when this code runs, might not contain the latest entered password, because of how React schedules state updates. That's what I preached before and why I urged you to use the function form. But again, it's not available here because we're depending on two other states and not the last snapshot of this form validity state. This is another scenario where you could use useReducer. So it's a good use case, a good replacement of use state when you have state that belongs together, like here with the entered value and the validity of the value, and or if you have state updates that depend on other state. And actually, we don't even have to go back to this code. We already violate this rule of using the function form if a state update depends on an older state here in our validate email and validate password handlers. There we are calling set email is valid and set password is valid to set new states for this email is valid and password is valid state. These are our two states which we're setting there. Now, how are we setting these states? Well, by having a look at another state and calling a method on it. So we're having a look at the entered email state, which is a different state. This is our entered email state. It's a different state than our email is valid state. Sure, they are related. They both change because of what the user entered. But technically, these are two different states, two different variables. And we are deriving our new email is valid state by looking at another state. And that is something we should not do. It works in most cases, but in some scenarios it could not work because maybe some state update for entered email wasn't processed in time. And then we would try to update email is valid based on some outdated entered email state. So we should use the function form here, but again, just as with set form is valid, we can't, because with the function form of our state updating function here, we only get the latest state for that state which we're setting here. So we would get the latest email is valid state, not the latest entered email state if we use the function form here. So that's why this is not an option. And therefore here we are already violating this rule, which I told you to, well, not violate. And that is a scenario where useReducer is always a good choice. If you update a state which depends on another state, then merging this into one state could be a good idea, and you can do that without useReducer as well. You could simply manage an email state, which is an object with the value and the valid being part of the same object. You could do that with use state. But in such cases, when your state becomes more complex, bigger, and combines multiple related states, use reducer can also be worth a closer look. And that's why we'll dive into it in the next lecture. So with that, we know when we might want to use reducer. How does it work though? It looks like this, and that's quite a bit of code. So let's have a look at this step by step. Use reducer, just like use state, always returns an array with exactly 2 values, and therefore you can use array destructuring, as we did it with use state, to pull out these values and store them in separate constants. Now the 2 values you're getting are the latest state snapshot, because it is a state management mechanism like use state, so of course you get your state snapshot. But you also get a function that allows you to update that state snapshot. So that's kind of the same as for use state, though the state updating function will work differently. Instead of just setting a new state value, you will dispatch an action. And that action will be consumed by the first argument you pass to use reducer, a so-called reducer function. So this is a function which gets the latest state snapshot automatically, because this function will be called by React, and it gets the action that was dispatched, because React will call this reducer function whenever a new action is dispatched. So then it gets the last state snapshot managed by React, and it gets the action that was dispatched that triggered this reducer function execution. Now, the reducer function then also should do one important thing. It should return a new updated state. So it's a bit like the function form of the use state hook, but an extended version of that, you could say, because of that action thing, which you'll see in action, no pun intended, in a second. In addition, you can also set some initial state and also an initial function that should run to set the initial state in case your initial state is a bit more complex and, for example, the result of, let's say, a HTTP request or anything like that. We'll ignore that for now. So that's use reducer in theory. Let's see it in action. Now, I did mention that we could use reducer here to combine our entered values and validities for the email and the password, and that we could also use it to manage the overall form state with it. So we could either manage one big form state that includes everything or multiple smaller states. Both would work, both would be fine, but to keep things simple here, we will simply start by managing our email state with use reducer. And there the goal is to combine the value and the validity into one state managed by use reducer. First of all, we need to import use reducer here. And we then call it, for example, here. And use reducer, as you learned, returns an array with exactly 2 elements, and we can use array destructuring to pull those elements out of it. Now, I'm going to use reducer for my email and my password separately. You could also merge this all into one big reducer. And here we therefore get back, let's say, the email state and our dispatch function. I'll name it dispatch email. These names are up to you, of course. Then I mentioned that use reducer as a first argument takes a function. Here again, I'm using an anonymous function, though we actually could also outsource this into a separate named function, maybe to make this easier to read. And I'll name this email reducer. And I'll store my function, my arrow function, in this constant so that I can point at email reducer here. Now please note that I created this reducer function outside of the component function. And I did so because inside of this reducer function, we won't need any data that's generated inside of the component function. So this reducer function can be created outside of the scope of this component function because it doesn't need to interact with anything defined inside of the component function. All the data which will be required and used inside of the reducer function will be passed into this function when it's executed by React automatically. So that's why we can define it outside of the component function here. Now this reducer function receives two arguments, two parameters: our last state snapshot and the action that was dispatched. And you'll see what this action is in just a second. And we should return a new state. Now here our state could be an object where we have the value, which is initially an empty string, and let's say the isValid field, which initially is false, for example. That also could be our initial state here, which is the second argument we pass to useReducer. Value and isValid to false. That's the initial state we set here for our email state snapshot. Now the email state is therefore what we can use in our code. For example here, where I want the entered email. Now that's email state.value, because that's where we're going to store the entered value. We don't have the code for that yet, but soon we will. So that's where we could access this. Also here, email state.value includes add. But actually keep in mind that we have the isValid field in there. And we're going to add code that changes it eventually soon. So instead of revalidating here, we could also just check if email state isValid is true. And therefore we can simplify this here. Email state is valid. And if we scroll down further here in the submit handler, here we want to forward the value. So that would be email state.value. And in the JSX code, of course, instead of email is valid, we have email state is valid. And here, where I pass the value back into the input, we have email state.value. And that should be the different places where I'm using my email states. With that, entered email and email is valid should now be gray because we're not using them anywhere in our code anymore. So we can remove these two use state calls here, and I will comment them out so that we still see this alternative, but we're not using it anymore. But we're not done with the reducer. Right now it always returns this state, which of course is not what we want. Instead, we need to dispatch an action eventually. We need to dispatch it here, for example, when we want to update the value, or here when we want to update the validity. Now let's start with the value. Here we now update this by calling dispatch email, and we pass to it a so-called action. Now it's totally up to you what this action is. It can be a string identifier, something like new email value. It could be a number, but often it will be an object which has some field that holds some identifier. Often the field is then named type, and that could be something like user input, for example. Now it doesn't have to be all caps, that's just a convention you see a lot. So a string all caps with some clearly understandable identifier. And then we also can add an extra payload to this action. Again, I'm saying you can because it's up to you. But here, since we want to save what the user entered, we of course, it would make sense to add some payload. So for example, a val field that holds the event target value. So now that's our action. It's this object with a type field that describes what happened and extra payload, in this case, the value the user entered. So this now will trigger this function here to execute because that's the reducer function we passed to useReducer. Now here we can handle this action, for example, with an if statement. We can check if action.type is equal to user input. Keep in mind, what we dispatch as an action will be an object because that's what we set it to here. And this object happens to have a type field, so I can check for action.type here and check if the value stored in that type field is that string with the content user input. And if that's the case, we could say, now then I don't want to return this empty state snapshot. Instead, I want to return a state snapshot for my email where the value is action.val. That's the payload we appended to our action. And maybe we also want to update the validity here if we're already added. Simply by, for example, checking if action valid, and then the same logic as down there, includes the @ symbol for this very trivial validation. So here I'm then updating both the value and is valid whenever I receive this user input action. And for any other action that might reach this reducer, this default state will be returned. Now, we also need to dispatch an action here on the validate email handler. So instead of setting the email as valid here, I can dispatch email again pass in an object. You should be consistent. Your actions should always have the same structure so that your code where you, for example, try to access a type property does not suddenly fail. So once you decided for an action structure, you want to stick to it. Therefore, here I again dispatch an object with a type field. Now here it's, for example, input blur, because the input lost focus, it was blurred. And we don't need to add a value here necessarily, because all we care about here is that the input lost focus. There is no extra data that needs to be added. So here we have a simpler action, so still an object, still with a type property, but without a value. The fact that the val is missing does not matter, because this line here, where we try to access the value, will not run for action of type input blur, because we only run this if the action type is user input. Instead, I will check if the action type is input blur, and if it is, I want to return a new snapshot, a new state value for my email state. But now the value, of course, should be the value we had before. I don't want to reset this to be empty because the input could blur after the user entered something. I don't want to lose that. So therefore, I'll use my last state snapshot, which I get here. And this is guaranteed to be the absolute last state snapshot. React gives us this state snapshot and it makes sure that it's the latest one. So here we can safely access state.value, for example, to access the last value that was entered for the email. And for the validity, we can therefore check if state value is valid by again repeating our validity check here. And of course, you could also refactor this check into a function, but I don't want to make this overly complicated. So with this, we now have this extra action. And as a result, if I log out here, you see initially it's blurred, which makes sense actually, because my initial value for is valid is false. If I set this to undefined or to null instead, you'll see it's not treated as invalid. It's not treated as if it was blurred from the beginning on. But if I click in there, it is. And if I then start typing, I'm getting an error. Cannot read property includes of undefined. And what could be causing that? Well, it looks like we're having problems running this code here, because that clearly has to be the action that triggered. And that's simply because here I'm checking action valid. Of course, it should be action val. So the value I'm retrieving here. So a simple typo here, my mistake. Let's reload. Now I can type here, and that all seems to work. And overall, this works as before. Without the debouncing, because I commented out that code, but the general form validation works. Now with the help of useReducer. And this allows us to group this email state together and manage it in one place. It's a little bit more setup up here, but on the other hand, the code in the component then is simpler, because there we only need to dispatch and not do any validation or anything like that. So here's a task for you now. Take this, attach to find the finished code snapshot, and do the same for the password. So, were you successful? Let's do the same for the password. Of course, it should be fairly trivial. We create our password reducer. which is an anonymous function that gets the last state and the action. And yeah, well, we can't just copy this, can we? We can copy this in here. The validation code needs to change because for the password, I'm checking the length. So I want to copy this code down there and use this here and here. The action names can be the same. But now, of course, we also need to call useReducer again here. Now for the password reducer. And what we get back, therefore, is the password state and the dispatch password function. We also want to set an initial state, which can be the same one as here for the email, of course. Just this object with no value and a null is valid state. And now we simply have to update the code accordingly. SetForm is valid. Here I'm not interested in the entered password, but instead, now that we do validation in here, I only want to access my password state, and there the isValid prop. And when the password changes, I want to call dispatch password, pass an object where I have the user input type and the val field, which is the event target value. And here, when the password field blurs, I also have dispatch password, and the type is just input blur. And here I'm not caring about the entered password, but the password state and there the value entered by the user. And then we can go down, and for the password field here, we have password state is valid in our check, and we feed back the password state value into the input field. And if I go up, we see we use nothing here, so we can comment out these two use state calls. And with that, again, if we give this a try, this all should work just fine, and it does. Now that wasn't too difficult, hopefully. It's again the same what we did for email reducer. And of course, you might see potential here for using just one reducer function instead of two, because it's almost the same. The validation logic is different though, so that's definitely refactorable, but takes a little bit more work, which is why I'm not going to do it here. But generally, it's not too far off. And in addition, and that's the thing that matters more to me here, the form validity, of course, also is a bit related to the input validity, because the inputs are part of the overall form. So the code we have here is still not optimal, because we still derive the form validity off of our state, which is still not what we want, due to the reasons I explained earlier with React scheduling the state updates. So we might still refer to an old state here that does not change just because the state is coming from a useReducer. SetForm is valid, like this still is not optimal. And in addition, having our state that is split like this, even though it technically belongs together, is also not something you might want. Now, whether you want this or not is up to you, but the fact that this is not optimal is a fact. So for this, let's comment this out again, and let's go back to the useEffect solution, which actually is a nice solution. So we can go back to this and just update it accordingly. Here we have the email state, and there simply is valid instead of doing validation here. And the same for the password. We have the password state is valid, just like this. And hence here we care about the email state and the password state. And this would now be a fine way of calling setForm is valid, because since it's now inside of an effect, we still refer to our state snapshots, but this effect is guaranteed to rerun whenever these states change, and therefore ultimately it will run with the latest state values. So this actually is now an okay way of updating a state based on our state, because with useEffect, we're guaranteed that this will run for every state update React performs. which was not the case before, where maybe the code ran too early. UseEffect only runs after state updates, so here this is okay. Now still here we have a problem though, which is why I'm showing this to you. This now will run accordingly and correctly, and hence here, indeed, if I enter something here, eventually this unlocks and works. But the problem we'll have here is that this effect runs too often. This will run whenever the email or the password state changed. Now that includes cases where maybe just the value changed, which might not be what we want. We actually only care about the validity here. Now it turns out that we update the validity now whenever the value changes as well. But of course, if, for example, the input was valid already and we then add an extra character to the password, it doesn't really change. It was valid before. With the extra character, it's still valid. So here, for example, if I have a password that is valid, if I add one more character, it's still valid. Nonetheless, our effect re-executed here. Now that's something we might want to avoid, and it re-executes at the moment because our dependency is the entire email and password state, not just the validity part of it, which is actually the part we're interested in. Here we can use a technique which you need to know, which is why I'm showing it to you. We can use object destructuring, so the same as array destructuring, just with objects, to pull out certain properties of objects. For example, from email state, we can extract isValid and store it in a new constant of the same name. And we can do the same for the password state, but since I'm already using isValid in this constant now, we can use a variation of the object destructuring syntax. We can add a colon here, which now won't assign a value because we're not creating an object here. We're using it on the left side of the equal sign. This is simply the syntax for object destructuring. And with the object, we now assign an alias to the extracted value, to the extracted property. So we're pulling out the isValid property, but we're storing it in a constant which actually could be named email isValid. And the same here for the password. We're pulling out the isValid property, but we can store it in, let's say, a password isValid constant. So this is an alias assignment. This is not a value assignment. It's an alias assignment because it's part of this object destructuring syntax, which is the syntax you're automatically using if you're using those curly braces on the left side of the equal sign. And now we have the email and password isValid constants, which we can use here as our dependencies and as our values. Your dependencies should be matched by your values and the other way around. So email isValid and password isValid. Now the advantage is that since now I'm pulling out the isValid state here, whenever just the value changes and the validity did not change, this effect will not rerun. And you can see this. If I enter something here, of course, in the beginning it will run. But once the password is valid, if I type one extra character, you don't see an additional checking for invalidity output. This is especially clear if I clean this. You see, I can type a lot of characters. This never checks again because the validity did not change. Of course, that's not the case if I make it too short. So I wanted to show this because this is an important concept to further optimize UseEffect and to avoid unnecessary effect execution. Not just when using it with useReducer, but for example also when doing so. Another use case could be if you have props as a dependency for your effect. You don't want to rerun the effect whenever props change, you only want to do so when some props change, for example. With object destructuring, you can get there. So that's a little step back here to UseEffect, but an important one. An equally important concept, of course, was useReducer though. So now that we learned about useReducer, let me again sum up when you should use useState and when it might be an idea to use useReducer. Now, generally, you will know when you need useReducer. That might not be the greatest rule of all times, but you will see when you need useReducer, for example, because using useState becomes too cumbersome, you find yourself dealing with a lot of kind of related state snapshots which still are kind of independent, and you start updating them together in a way that just doesn't work out, then you want to consider using useReducer. Now, to still give you a couple of ideas when to use useState versus useReducer, useState is your main state management tool. Typically, you start with useState, and often it's all you need. It's great for independent pieces of state and data. It's great for simple state, you could say. It's great if state updates are easy and limited to a few kinds of updates. So if you don't have a lot of different cases that will change a state, and especially if you don't have, let's say, an object as a state or anything like that. Now, if you do have an object as a state or a more complex state, useReducer might be interesting because in general, useReducer is great if you need more power. And with more power, I simply mean that you can write such a reducer function that can contain more complex state updating logic, where you always are guaranteed to work with the latest state snapshot, and where you can move that potentially more complex logic out of your component function body into a separate reducer function. So also to restructure code, that might be interesting. You should especially consider useReducer if you're dealing with related data with state that is made up of related pieces of state. So when you, for example, have a scenario as we had it with our form input state. And in general, useReducer can be helpful if you have more complex state updates, if you have different cases, different actions that can change a state, cases like this. Now, there is no hard rule, and there, as always in programming, is no clear wrong or right. You can certainly also handle cases where useReducer would be good with just useState, especially when combining that with useEffect. But sometimes using useReducer just might be more elegant or simpler. On the other hand, you should absolutely not always use useReducer, because often that will be overkill. If you have just a simple state that just switches between two different values, for example, using useReducer might be overkill. And that's it for useReducer. Now, you could absolutely also use useReducer to manage the form state as a whole with useReducer instead of using useState for the form validity. You could replace these two reducers and the form validity with one big reducer that manages the entire form, but that's something I will come back to later in the forms module, since for now, it's just important that you understand useReducer and when to use it. So with useReducer out of the way, let's dive into a different problem you might face in bigger React applications specifically, but even in this tiny demo here, we already have it, that can be solved in a more elegant way. I'm talking about a problem, in quotes, where you are passing a lot of data through a lot of components via props. And a good example here is our isLoggedIn state and the login functions. We're managing this state in the app component because I lifted this state up to that component because we basically need this state, this isLoggedIn state, and the functions to change it everywhere in this application. We use the logged in state in the header, to which I'm passing it through the isAuthenticated prop. From there, we are able to log out. So I pass the pointer at the logout handler to my header on the onLogout prop. And we also need the login state to render different content here, either the login or the home component. And to those components, I also pass the logout handler or the login handler. Now, the logout handler being passed to the home component, that's something I'm doing here so that we theoretically could add a button there with our button component, for example, to allow the user to log out there as well. Not something we need in this app, but something you could add here with props on logout, since we're getting a pointer to this handler anyways. And if you do that once you log in here, You also have the logout button here. So long story short, we need or we use this login state in a lot of different places in the app. Now, obviously, this is a very, very, very simple app, a very simple demo, and here, passing our state around like this is not a huge problem. Now, it is quite common that you pass data to components through props, but it's always a problem if you forward state through multiple components. So if you basically just leverage props to forward data to another component. And that's actually something we're doing in the main header. Here in the app component, I'm passing isLoggedIn through the isAuthenticated prop to main header. And I'm passing the logout handler through the onLogout prop to the main header as well. Now in the main header though, I'm using neither of those two props. I'm using them only to forward them again to the navigation component. Because it's the navigation component in the end which needs the isLoggedIn data to render different links, and which needs the onLogout prop and the logout handler therefore to do something when the logout button is clicked. So essentially what I'm doing here is in the main header, I'm receiving props, I'm receiving data through props, which I'm not actually using primarily in the main header. Instead, I just forward that data. That's not necessarily a problem, but in bigger apps, that chain of forwarding might become longer and longer. Consider this example of a fictional app. We could have an app with an app component, with let's say an auth section with a login form, with a shop section where we have a list of products in which we render individual product items, and with a cart. Now in the login form, we might have the login event when the user fills out the form and submits the form, and we validate the data and find out that the user is logged in. And we might need that login data, so that login status, the information that the user is logged in different parts of the app. We might need it in the shop, we might need it in the cart, to show the cart, to avoid that the user can go there if he or she is not logged in. It's easy to imagine that we need information about the login status in different parts of the app. And we have something similar. Let's say the user adds a product to the cart. We need that information in the cart component to show the product there, for example. But since the product is a direct child of products, which is a child of shop, which is a child of app, and since the login event happens in the login form, which is a child of auth, which is a child of app, we don't have those direct connections to the other components where the data might be needed. If a user clicks a button in the product component to add a product to the cart, the information needs to reach the cart component, but there is no direct connection between the product component and the cart component. And the same for the login. And therefore, what we typically would do is we would use props to pass a function handler to the login form, for example, so that in there we can call it. But that essentially means that we're forwarding data through our different components. And the same, of course, if we add something to the cart. Now, that means that this function that should be triggered when the user adds something to the cart would probably be managed in the app component, because we lifted the state up to the level where we have access to both the product component indirectly and the cart component. And that's only the case in the app component. Only this component has at least indirect connections to both components, product and cart. And therefore, we would forward a pointer to the add to cart function through all those other components, the shop component and the products component, even though those components probably don't need that function. They only need it so that they can forward it to the product component in the end. So in the end here, we have the same problem I described here, just on a larger scale. Here it's a very simple app, but even here we are forwarding data through the main header to the navigation component on props we receive in the main header, even though we don't really need the data there. So therefore, in bigger apps, you could easily build such prop chains which are used to forward data through components to other components. That's something you can do, and that's not necessarily bad, but the bigger your app gets, the more inconvenient it is to do that. Instead, it would be nicer if we could use props in a component to only receive the data this component really needs from its parent, and not to forward other data through the parent, which the parent does neither manage nor need itself. And for that, we got a component-wide, behind-the-scenes state storage built into React. We have a concept called React Context, and this in the end allows us to, for example, trigger an action in that component-wide state storage, and then directly pass that to the component that is interested without building such a long prop chain. And that allows us to solve our problem in a more elegant way here. So let's take a closer look at this now. So as I mentioned, we have this React Context concept, which allows us to manage state kind of behind the scenes in React, such that we actually are able to directly change it from any component in our app and directly pass it to any component in our app without building such a prop chain. For that, here in my source folder, next to my components folder, I will add a new folder, context, and you don't have to name it context. You could also name it state or store. Often such an app-wide state is also named store, so maybe let's go with that. And in there, I'll add a new file. And since we're going to manage some authentication state, I will add a auth context in there. So hence, I will name the file authcontext.js. The exact naming is up to you though. You could also name it auth context like this, so in this Pascal case notation, but this would imply that we're going to store a component in there, and that's not directly what we're doing. Hence, I'll go for this naming using kebab case. So auth context.js, and I can say right away, you can have multiple contexts for multiple global states in your app. And of course, you can also use just one context for a bigger state. That's all up to you, but let's maybe just learn how context works. So we get the auth context.js file. And in there, we import React from React as if we would build a component, but we're not going to do that. Instead, on React, I'm going to call create context. And this does what the name implies. It creates such a context object in the end. Now, create context takes a default context. And context here really is just your app or component-wide state. So it's up to you what that state should be. It could be something simple like just a string, my state. If your app-wide or component-wide state is just some text, you could have some, well, text as your default state. Often though, it will be an object. It will be an object where you, for example, in our case, manage the isLoggedIn state and set this to false initially, let's say. Now what we get back from create context is something interesting though. It will be a component, or it will be an object that also contains components. Let's put it like this. So we get back auth context, and I'll name it like this because whilst auth context itself is not a component, it is an object that will contain a component. Now we don't need this object here though. Instead, we'll need it in the other components. So I'll export it as a default to make it available in other files. So now we can import this specific context object. And to then use context in your app, you need to do two things. You need to provide it, which basically tells React, hey, here's my context. All components that are wrapped by it should have access to it. And I'll come back to that wrapping part in a second. And besides providing, you then need to consume it. You need to hook into it. You need to listen to it, if you want to call it like this. Now, providing is always the first step. Providing means that you wrap in JSX code all the components that should be able to tap into that context, so that should be able to listen to that context. Any component that's not wrapped will not be able to listen. So here, if we know that we need this context everywhere in the entire application, so in all components possibly, we want to wrap everything in app component with it. If we knew that we only needed, let's say, in the login component and its child components, we could only wrap the login component. But here we'll need it in the main header, we'll need it down there, we'll need it everywhere. So therefore, we can wrap our main header and this main section with auth context, and for that we'll need to import it. So make sure you add this import from store auth context to import this auth context object. And I said that this itself wouldn't be a component. In JSX, we need a component though. But with a dot, we can access a property on this auth context object that contains a component. And that's the provider. Auth context provider is a component we can use in our JSX code, and we can wrap it around other components. And those other components and all their descendant components, so all their children and their children's children and so on, all those components will now have access to that context. Now, since we use auth context as a wrapper here, we can now technically also use React fragment because we got this wrapping component as a root level component I return here. And with that, the main header, but also the login and the home component and all their children will have access to auth context. So now we provide this. Now we have the second part, and that is the listening part. To get access to our value, which at the moment is always just this default value, which never changes. We're going to work on that too, of course. But to have access to that value, we need to listen. And we can listen in two ways. We can listen by using auth context consumer or by using a React hook. Now we'll typically use the React hook, but let me show you the other alternative to consumer as well. Let's say here in navigation, we're interested in knowing whether the user is authenticated or not. For that, we can also use auth context there and wrap everything where we need data from it with that consumer. So here, for example, we could wrap the entire component with auth context. Again, make sure to import it, of course. Dot consumer now. Previously, we had the provider. Now we have the consumer. The consumer works a bit differently, though. The consumer takes a child, which actually should be a function between curly braces like this. And as an argument, you'll get your context data. So in our case, you'll get this object here. And then in this function, you should return your JSX code, which should have access to that data. So here I'm grabbing all that nav code, I'm returning that. And in there, I now, for example, have access to ctx.isLoggedIn because my context object is this object here, and there I have the isLoggedIn prop. Now, if you save that, you will, however, see, if you reload, that this crashes. And the reason for that is that we do have a default value here, but this default value will actually only be used if we would consume here without having a provider. So technically the provider is not even needed. However, you should memorize this pattern I explained earlier where you need the provider. Technically, you don't need it if you have a default value, but in reality, you will use context to have a value which can change, and that will only be possible with a provider. So therefore, to make sure that this does not crash, let's go back to the provider. And there, on the provider component, you can add a value prop. And this has to be named value because this is not a component by you. And to that, you can also pass your object. So in this case, I will just repeat my default object here. But now you would be able to change that object, for example, through state in the app component. And whenever it changes, the new value will be passed down to all consuming components. But that is something I will also come back to in a second. So here, let me save this, and now it reloads without problems. Now, of course, if I now log in, you will see that we only have one link here. So that first link, the user's link, is missing because there I'm pulling data from my context, and that at the moment is never changing. So let's make sure we can change it before I then show you the alternative to the consumer. Here, changing it is easy. We have set up the provider here in the app component, and there we manage the isLoggedIn state anyways. So instead of hard coding our isLoggedIn value in the value we pass to the provider, we can set it to isLoggedIn, of course. And if we do that, this value object will be updated by React whenever isLoggedIn changed. And that new object, that new context object, will be passed down to all listening components. So to all components where we consume this context. The difference to before is that we don't need to use a prop to forward that, therefore. Instead, we just set it on the provider, and then everywhere in all child components, we can listen to that. So here we could remove the isAuthenticated prop on the main header, and in the main header, therefore, stop forwarding it to the navigation. And in navigation, we could now use context.isLoggedIn everywhere where we need the isLoggedIn information. And that's now where we break up that props chain, where we stop forwarding that data, which we don't need in the main header, and where we instead leverage context. So now if I reload, you see that still works, and now the link is back, but now we're using context here. Now I did mention, however, that the consumer is just one way of consuming our context. It's an okay-ish way, but I don't like that syntax too much, having that function that then returns our code. You can do that, but there actually is a more elegant way, a more elegant solution using the useContext hook. So let's explore the useContext hook. For that here, I will actually remove this code. I will remove the consumer like this. And therefore I'm back to my old navigation component, but of course now I'm referring to that CTX object which simply doesn't exist anymore. Now we're still importing auth context, and we can use it again now by importing a hook from React, and that's the useContext hook. Another hook that's built into React. And it does what the name implies. It allows us to use the context. It allows us to tap into a context and listen to it. Using it is simple. You call useContext in your React component function, and you pass the context, a pointer at the context you want to use, to it. So in our case, I'm pointing to auth context. Now what you get back is the context value. So here, I'll store this in a CTX constant to make my code down there work again. And with that, we can save this, and it will again work just fine, simply because I'm using the useContext hook. Easy like that, simple like that. This is all we need to do, and this, of course, I would say is a bit more elegant and a bit nicer than using auth context consumer, which you, however, just to make this clear, are also allowed to use. It's not wrong or anything like that. This is just a bit more elegant, in my opinion. So we're using useContext to pass the isLoggedIn state to my other components here. That's great, but of course you will notice that we're still forwarding the onLogout prop or the logout handler function through props, and that's of course still not ideal. It would be nicer if we could use the main header like this, so without passing any data to it, because we don't need to forward onLogout. But of course at the moment this would not work. This would mean at the moment that we're simply not able to log out because we're not passing our logout handler. So hammering the logout button here in the navigation wouldn't do anything. The good thing is we can set up a dynamic context where we don't just pass data to our components, but also functions, which technically of course also is data, but still you get my point. Here all we need to do is in our auth context provider, where we set up the value, besides passing down isLoggedIn, we can also pass down, let's say, onLogout, where we point at the logout handler. Just like this. If I do that, and make sure you don't execute it, you just want to point at the function. If I do that, then every listening component, every component that listens to auth context will be able to utilize logout handler here, simply through the onLogout context value. So therefore, back in navigation, where we are referring to props onLogout, we can now simply do CTX onLogout. And this will work because on the context object, we now have the onLogout value. So if we save that, now logging out works again. And of course, the rest of the app also works just fine, as you can tell. So this now all works, again, with the help of context, where you can not just pass down values like strings, objects, and so on, but where you can also pass down functions. And therefore now we're using this app-wide or component-wide context object to manage our state and to manage the function that changes the state. Hence, we don't need props in the navigation component anymore. And we can remove it. And you now have a great example for using context. Now here, in my main section here, I will still pass down the logout handler through onLogout and the login handler through onLogin because I directly use those handlers in the login and home components. You see in the login component, we directly refer to props onLogin. We're not forwarding it, we're using it here. And the same in the home component. I'm directly using onLogout here. Sure, we're technically forwarding it to our own button component, but this is a pure presentational component. And this here is actually fine. I don't want to use context inside of my button to always bind button clicks to onLogout, because whilst this would remove the need to pass onLogout like this, it would also mean that our button is now always logging the user out and not able to do anything else upon a click. And this also shows you when to use props and when to use context. In most cases, you will use props to pass data to components, because props are your mechanism to configure components and to make them reusable. Only if you have something which you would forward through a lot of components and you're forwarding it to a component that does something very specific, like for example the navigation, where this button will always log the user out. In such cases, you want to consider context. And as with everything in programming, with more experience, it will also of course become clearer and more natural when to use what. You can of course always rely on prop chains if you prefer that, but context allows you to write more concise code, and it often makes managing such app-wide state simply a bit easier. Now, a little enhancement to our context. It is a good idea to also add your functions, like onLogout in my case, to the default context when you create the context. And there you can just store a dummy function which does nothing. I'm doing this for better IDE auto-completion, because you will see that if I don't have this here, in the navigation component, here if I try to call onLogout, I'm not getting any suggestion by my IDE. It doesn't know that there is an onLogout prop. On the other hand, you will see that there is this isLoggedIn suggestion. Now that's simply happening because the way React works and the way Visual Studio Code at least works, it's looking at this default context object to find out what you are able to access on your context. So for better IDE auto-completion, it is a good idea to add onLogout here in your default context object as well, just with a dummy function, because we're not going to use this anyways. And then here, you will see that now I get this onLogout auto-completion. So that's just a tiny hint you might consider because it can be helpful. Another thing that you might consider is, depending on your application structure and how you're managing your data, you also might want to pull more logic out of, for example, app component and create a separate context management component, if you want to call it like this. How could this look like? Well, maybe in our auth context store file, we could create a auth context provider component now actually, where we return auth context.provider, and we accept props and simply pass whatever we got on props children between our provider. And then here, I don't just export auth context as the default, but I also export my auth context provider in addition to the default as a named export. Now, why am I doing that? Because now we can actually also import use state here inside of the auth context.js file and manage the is logged in state and set is logged in here inside of this auth context provider. Add the logout handler function here where I set is logged in to false, and also add the login handler function here now, so that we manage the entire authentication state in this separate provider component. And here I set is logged in to true, of course. And then I set the value here, of course, to an object where I have is logged in, which is equal to the is logged in state, where I have on logout, which points at the logout handler, and in addition, where we now also have on login, which points at the login handler. And therefore, I will also add this to my default context here, on login, with a dummy function, just making it clear that we there want an email and a password. We're not doing anything with that data, but technically we would need it in a real app. And now we have this standalone file which manages the entire login state in this auth context provider component, and which also sets up all the context. And the advantage here could be, and I'm saying could because this is something you can consider, it always depends on your preferences, the exact use case, and the size of your app, but this is something you could consider because now we can strip that all out of app component. We of course also though need to move over our local storage access here. So clear data in the logout handler, set our data in the login handler, and of course also add our use effect code here. That all now needs to go into our auth context provider, and therefore we also need to import use effect here. But with that all, we can now clear all that logic here from the app component, remove these hook imports here, remove our auth context import here, remove all of that, and therefore, of course, bring back React fragment like this. And I'm doing this because now we can wrap the app component as a whole, so therefore an index component, which is where we render the app component, with auth context provider. So with our auth context provider component, which we just created and exported in the auth context file, and with that, we have one central place for the state management, for the auth state management, I should say. And that central place is now not the app component, but a dedicated context component and a dedicated context file. And this might be a structure you might prefer because it is more focused and gives you a leaner app component, which now is not concerned with app-wide state management, but which now instead can just focus on, well, bringing something onto the screen. Of course, since I'm now using is logged in here, I need to be able to get that information. So now in the app component, we want to use context and pass our auth context, not the provider, but still the auth context object, which is our default export in the auth context file. And therefore, we now got our context here as well, and hence we can access it here. And now we could even remove the on login and on logout props here, because we're not managing the logout and login handlers in app component anyways. And now tap into context in the home and login components. So in the home component, we can now also import use context and get access to our auth context, maybe to mix up the naming and make it clear what's in there, to which context we're listening here, by importing auth context and passing it to use context. Again, use auth context here, not the provider. And then here we can use auth ctx.onLogout and do something similar in the login component. Import use context here And then in our component function, maybe here, we can set up our auth context by calling use context and passing auth context to it. For that, make sure you are importing auth context, of course. And then we can use auth context when we need to log in. So here it's not props on login, but auth CTX on login, to which we forward the email and password. Now, again, this is totally optional. The advantage here could just be that you have a leaner app component, which again is now just focused on returning JSX and bringing something onto the screen, and you have the actual auth state management and auth context management all in one file. And some developers, including myself, often prefer this more focused and separated approach, where you have components where every component has one job essentially and not a ton of jobs. And therefore I'm a fan of this split, but as so often it's not the only way of doing this, and it's also not the only correct way. It's definitely a practice that is worth looking into though, a practice you might see in projects out there, and therefore something that of course needs to go into a course like this, which has the job of turning you into a real React developer. And therefore you have to know patterns like this, which is why we refactored this. With all of that out of the way, let's test our application to ensure that this still works. And that all seems to work to me here. Let's also check the logout button here. Yeah, that all works now with one central context, with one central state management. So React context is great. Let's use it for everything. Well, not quite. For one, keep in mind what I mentioned earlier. It can be great for app-wide or component-wide state, so essentially state that affects multiple components. It's not a replacement for component configuration. Consider our button here in the UI folder. The button should be reusable. Sure, we could use context to make sure that upon a click we always log the user out, but that would mean that we can't use the button for anything else than logging users out. And that might not be what you want. For example, in this application, we are using the same button component in the login component to log the user in and trigger the form submission, as well as we're using it in the home component to log the user out. So that is a scenario where using context in the button component would be bad. You want to use props here to configure the button. So props for configuration, context for state management across components or possibly across the entire app. But even then, we have limitations. React context is specifically not optimized for high frequency changes. So that means, for example, if you have state changes every second or multiple times per second, this is clearly not the case in our example here. For authentication, that does not change that often. It changes once every few minutes in reality, maybe not even that. So that is a perfect use case for context. But if you had state changes that happen much more frequently, again, talking about multiple changes per second and so on, then React context is not optimized for that. And you don't have to take this from me. This is actually something that was stated by an official React team member. So it's not great for high frequency changes. Now you might wonder, okay, but what if I have app-wide or component-wide state that changes often? I would want to use context for that. Props might not be ideal, and you're telling me that it's bad. We'll explore a better tool for that later, no worries. It will be called Redux, and I'll have a whole section on it. And as I mentioned, it should not be used to replace all component communications and props. Props are still vital and important for component configuration. So you should still use props for that and not use context for everything. For replacing long prop chains, it might, however, be worth a look. So now in this module, we learned a lot of important new concepts, and we learned about new React hooks. Specifically, we can see it here in the login component. We knew about use state before, but now we also learned about use effect, use reducer, and also use context. So there are a bunch of React hooks. There are even more hooks than that, but we'll get there step by step. Now that we have all those hooks, it is important that we also learn about some rules for using them. We always followed those rules thus far, because of course I'm not teaching you incorrect patterns, but I think it's now also time to give you a formal definition which you can print out, put on your wall, and make sure you don't violate them. You find this slide attached therefore. Side note, all slides are always attached to the last lecture of each module. Anyways, there are two main rules you have to know when it comes to working with React hooks. And React hooks are simply all those functions that start with use. So use effect, use reducer, and so on. The first rule, which is important, is that you must only call React hooks in React functions. That means in React component functions, as we did it thus far, or also allowed in custom hooks. That's not something we explored yet, but of course that will also be included in this course. Just as the name suggests, it's a bit more complex and therefore a bit more advanced, and something we'll therefore dive in later. These are the two scenarios where you are allowed to use React hooks. And what does this mean? Well, to give you a concrete example, here in the login component, we for example have the email reducer function. This is a function next to the login function. The login function here, however, is my component function for the login component. And it identifies itself as such a function because it returns JSX in the end. That is what makes up a component function. Email reducer does not do that. It returns an object. It's not a React component, and therefore calling use state in here is not allowed. And the good thing is, a modern React setup with a good IDE like Visual Studio Code will even tell you about that. You see it down there. React hook use state is called in function email reducer, which is neither a React function component or a custom React hook function. So exactly what I stated on the slide. You're only allowed to use hooks in React function components or in custom hooks. Email reducer is neither of that, and hence we get an error. So you should get an error if you try to do that, should get a warning, and here is also your technical rule: don't do it. The second important rule is that you must only call React hooks at the top level of your React component functions or your custom hook functions. Don't call hooks in nested functions. Don't call them in any block statements. So again, to give you an example, here in the login component, so now inside of the functional component, we of course, for example, have our useEffect function here. So the function which we pass to useEffect. You're not allowed to call useContext or useState or any other hook in there. Again, you will see I get a warning here. React hook useContext cannot be called inside a callback. React hooks must be called in a React function component or a custom React hook function, and it needs to be called directly on the top level there. So calling it here is okay, because that's the top level of this login function, but in a nested function is not allowed. And that's not just true for nested functions, it would also not be allowed in an if statement. Calling use state in there, also not allowed. So again, a very simple rule, not too hard to follow. Only call React hooks at the top level. Now these are the two official rules of hooks. There is a third rule which I want to add here, not directly related to all hooks, but to one specific hook. And that's the useEffect hook. There, make sure that you always add everything you refer to inside of useEffect as a dependency, unless there is a good reason not to do that, I should add. And to make it clear what I mean, let's again go to login component. In here, we use useEffect to execute this function, and in there, we use nothing from the surrounding component. We use console log, but that's baked into the browser. I'm not talking about browser API things. I'm talking about data exposed by the surrounding function. And here we're not using any data, hence we have no dependencies. It's a different thing for this useEffect here though. There we have this function, and in there we're using setTimeout, which is a browser API. You don't need to add those. But we are using email is valid and password is valid. And that's data from the surrounding component. That's part of the surrounding component's state. And if it would be part of the surrounding component's props, the same would be true. So what I'm now saying would be true in that case as well. Such dependencies or such values need to be added as dependencies. Technically, we should therefore also add setForm is valid, because that's not a browser API. But this is one exception to that rule actually. The state updating functions exposed by useReducer or by useState are guaranteed by React to never change, and therefore you don't need to add them as dependencies, because if they never change, well, it's a redundant dependency. You could add it though. Wouldn't be wrong, wouldn't be horrible. You could add it and it would work in the same way. You are just allowed to omit it. And actually, you don't need to memorize all of that if you think, well, that's too much. No worries. If I remove a dependency here, in a modern setup, you should get a warning here that React hook useEffect has a missing dependency. Either include it or remove the dependency array. So, you are warned here as well, and I just want to explain this warning and why you are getting it. There are some exceptions, like the state updating functions, but all the other data, which is not coming from the browser or from outside your component function, so all the data that is from inside your component function in which you are using useEffect needs to go into the dependency array. That's my third rule here. And with that, you are well prepared to use hooks and to build amazing apps. Now let's continue on that road. Now there is one last hook, not in general, there are more hooks, but there is one last hook which I want to dive in right now because it fits really well into this section here, into this module. For that, we'll first of all have to change our code a little bit though. We'll create a new component, an input component, that contains our input divs and that receives all the data it needs through props. So that, just like the button, it's reusable, because we will indeed reuse it for the email and the password input. Now, feel free to try to create such an input component on your own and use it here in this login form. That's a little mini assignment, a little mini task you can dive in. Here's a short pause for you to pause the video, and thereafter we'll do that together, and thereafter we'll see which hook I'm talking about. So, were you successful? Let's do it together. For that, in the UI folder, I'll add an input folder with an input.js file, and in there from React, I import React because we're going to create a component in there. The input component which gets props and which we export here, just like this. Now, the JSX that should be returned here, as I mentioned, should be that div here. So I'll grab that div from the email, cut it from the login component, and add it here as a return value. And therefore, I'll also add an input.module.css file to bring over all the styles I want. So I'll import classes from ./input.module.css, and of course also migrate the respective styles. Here in the login module, I'm basically talking about all those control styles here. They are all related except for the actions. So actually I'll cut everything in front of actions because actions is part of the login component. Bring the control part into the input module CSS file though, and that of course then also includes this media query. Bring that over as well. And with that we got the styles migrated. Now back in the input component, we now got some data we need to get from outside. To make this reusable, I of course don't want to focus on just the email state here. Instead, I'm just interested in whether this input is valid or not. So I expect to get just a isValid prop on my props object here to then add this invalid class or not. This text here should be settable from outside, let's say on a label prop. This ID here should be settable from outside. So I will expect this on an ID prop. This type here should be settable from outside. The value should be settable from outside. And here the change and the blur handlers as well. So here I'll have on change, and here I'll have on blur. And this should be a quite reusable input component. And we can now use this here in the login component where we previously had that div. So there I'll add the input component. Of course, for that, make sure you do import it. You do import your input component here from the newly created input file. And now we need to configure that component. So for example, we need to pass our ID, email, our label, which was email like this, our type, which is email, and also the is valid prop, which is the email is valid constant, which we essentially have up here, pulling it out from the email state. That's something we want to forward. And of course, we also need the value prop that needs to be set on our email state value, and also on change and on blur. So on change here is our email change handler, and on blur is our validate email handler. And with that, we have our email input. Now we also, of course, need to migrate the password. So here we're going to replace this div with this input, but now for password, the label text should be password, the password and the type should be password. Here we have password is valid, we have the password state value, we got the password change handler, and we got the validate password handler here. So with that, we should have the same behavior as before, and we do, that works. But now we have the separate components here. Now that's a nice practice, and that's always good. And it's also a good example for when we want to use props versus context. We absolutely want props here because those input components, as you can see, should be reusable. And therefore we use props so that we can configure them from inside the parent where we are using them. If we would use context inside of the input, every input would do the same thing. It would be bound to the same context. It might be less reusable then. But that wasn't the main focus. This instead just now allows me to move on to the next hook, which I want to show you. The next hook I want to show you allows us to interact with the input components imperatively, which means not by passing some state to it that then changes something in the component, but by calling a function inside of a component, for example, which is something you won't need to do often and you shouldn't do often because it's not the typical React pattern you want, but sometimes it is helpful. Now it will become clearer what I mean in a second. First of all, let's remove this disabled prop from the button. I don't want to disable the button. It should always be clickable now. Second, in the submit handler, since the button is now always clickable, I want to check if the form is valid, and only if it is, I will call on login. Otherwise, and that's now the interesting part, I want to basically focus the first invalid input I find. So here it's now always submittable, and if I click on login, I now want to make sure that we actually focus the first input that is invalid. So in this case, that we put the cursor into the email input here. That's something you might want. So for that, I'll actually turn this into an else if statement and check if the form is valid because the email is not valid, hence the exclamation mark at the beginning, or else, if the email should be valid, it has to be the password that is invalid, then we'll go into this block. Of course, both could be invalid, but again, I want to focus the first one, which is invalid, and the first input we have that could be invalid is the email. Hence, I'm checking this first. But now the goal is to focus the input. And for a regular input, that would be possible by putting a ref on it, We learned about refs already in this course with the useRef hook. And then we could call the focus method. Just to show this to you, here in the input component, where we have the native input, the raw input HTML component, we could use the useRef hook here to create an input ref like this. And then, for example, if we would want to focus this after the component was rendered, we could use useEffect to run some code after the component was rendered. You learned that the function you pass to useEffect runs after every component render cycle. Let's say we only want to run it once when the component initially renders, hence I pass an empty array as a dependency array, so that this only runs after the first time this component was executed and rendered. And then here, we could focus the input by adding the ref prop to the input. The ref prop is supported on all built-in HTML components, like input, for example. Point at input ref, and in useEffect, we could now use input_ref.current.focus. And the focus method is a method that is available on the input DOM object to which we got access through this ref. So here we're just using refs. As you learned them earlier in the course already, we connected our ref to the input, and then we use useEffect to focus this input after this component rendered. And as a result, since the input will render for both the email and the password, this will focus the password input because that's the second and therefore last input that's being rendered. Hence, if this reloads, you see the first one is marked as invalid because it was temporarily focused, but then the password is the input that stays focused at the end. Now, that's not the behavior we want, but that's something we can do with references and the built-in functionalities we have in React and simply in vanilla JavaScript. Focus is a method that's not coming from React, but that's built into JavaScript, built into the DOM objects, the input DOM object specifically you're dealing with. Now again, my goal is not to do that after the input is rendered though, so we can remove useEffect. My goal is that I, for example, have my own method here in the input component. Let's say it's called activate. You could also call it focus, of course. And in there, I want to use the input ref, current, and focus my input. But now the goal is that activate is a function that's not called from inside the input, but from outside. Now I'll say it again, this is a rare scenario because typically you don't want to code your React projects like this. Instead, you want to work with props and state and pass data down to a component to then change something there. But in rare cases, like in this example, it might also be an elegant way of, focusing this input here, if you could call focus or activate on your input component, so that you essentially can use your input component as you can use the built-in one, because there you have a focus method as well, right? So maybe you want one, or in our case, an activate function on your own input component as well. So a rare use case, but you could face it at some point. Now, of course, you could think, that shouldn't be too hard. We go to the login component, where we have our inputs, and we simply use useRef here as well. UseRef, like this. Import the useRef hook. And then in your login component, you create your email input ref, for example, by calling useRef. And you create your password input ref by calling useRef. useRef. So that you have two references, one for the email and one for the password input. And then we simply go down and we add the ref prop here on the first input and point at the email input ref. And for the password, we also add ref and point at the password input ref. Could be as easy as that. Now, therefore, we have a reference to our own components now. One reference to our input component for the email and one reference to the input component for the password. And therefore, in the submit handler, if the email is invalid, if the email is invalid, we can use the email input ref, current, and call activate, which is that function we have in our input And we do the same basically in the else block, but for the password input ref. Right? This is something you might want to do. Well, if we try this, it will not work though. If I save this, you already see an error here. Function components cannot be given refs. So this will not work. We can't use a ref here. This is not possible. And our component, the input component, of course, also doesn't really do anything with a ref prop internally. It doesn't accept a ref prop on its props object. We're not using props.ref anywhere in there. But even if we do, ref is also kind of a reserved word. And yeah, we're getting this warning here for a reason. So this is not an approach that works like this. However, we can make it work. We just need to do two things. For one, in the input component, we need to import another hook, and that's the use imperative handle hook. Has a strange name, but in the end, it is a hook that allows us to use this component or functionalities from inside this component imperatively, which simply means not through the regular state props management, not by controlling the component through state in the parent component, but instead by directly calling or manipulating something in the component programmatically. And again, that is something you rarely want to use, and therefore you shouldn't use it very often in your projects as well. You want to find an alternative. Nonetheless, here it actually is a pretty nice solution for this problem. And all we need to do is we need to call use imperative handle here and pass two things to it. Let's start with the second thing before I talk about the first parameter. The second parameter is a function that should return an object. And that object will contain all the data you will be able to use from outside. So for example, here we could add an activate field or a focus field, totally up to you, and then point at the internal function or the internal variable or whatever it is that should be accessible from outside through that name. For example, here, point at activate. And again, this doesn't have to be focus, this can be activate or anything else as well. I'm just using different names here to make it clear that this activate refers to this function, and that is the externally available name then. So this is basically a translation object between internal functionalities and the outside world, so the parent component. Now this alone doesn't do the trick though. We also have this first argument which we need to provide to use imperative handle. And that's actually something we also get here in our component function argument list. Thus far, we always just worked with props, and in 99.9% of cases, that is all you will need. However, there technically also is a second argument you can accept, and that's a ref. Now that's interesting. That is a ref if a ref should be set from outside. We'll also need something else to make sure that this can be set, but this is then available. So if now the parent component, the login component, adds the ref prop and binds this to something, essentially this here will establish the connection. This will be part of allowing this binding. And it's this ref which we should pass to use imperative handle. Now we're still not there yet. This alone would not work. In order to enable this second argument here, we need to export our component function in a special way. We need to wrap it with something special. And that's coming from React, and it's called forward ref. And that is basically a function which we execute, a method which we execute, to which we pass our component function. So our component function is now the first argument to forward ref. And forward ref returns a React component, so input still is a React component, but a React component that is capable of being bound to a ref. Now, since I wrap forward ref here, I of course also need a closing bracket here. And now with that, input is able to take a ref prop, and it will expose a ref, and it is controllable or usable with refs. But the only thing you will be able to use is what you expose here through use imperative handle. So for example, here I'm exposing this focus function, a function because it points at the activate function. So now in the login component, we can call email input ref.current.focus because that's the external name we set up. And with that, we can save this. And if I now click login, you see the email is selected, the first invalid input. If I enter something valid here and I click login, you see the password is now selected because it's invalid. The same here. If I click out of it, but it's invalid, it is selected. And I can, of course, also still log in if everything is valid. So that is a niche use case, but especially for something like focusing inputs and so on, this can be very useful. So this is a very realistic use case, which I'm showing to you here. With use imperative handle and forward ref, you can expose functionalities from a React component to its parent component to then use your component in the parent component through refs and trigger certain functionalities. That is something you can do, and that does not just work for functions. We could also expose the value here through refs if we wanted to. So that is something you can do, not something you will need all the time, and you should avoid it at all cost, I would almost say. But especially in cases like this with focusing, but also in some other use cases like with scrolling and so on, this can be very useful. And then triggering something like this programmatically is fine. And with use imperative handle and forward ref, you are able to make it work.